So here is example 4 on solving systems of inequalities. I want to solve it by graphing, so I need to get y by itself in each equation. So in this equation, I will subtract 4x from both sides, and when I do, I have y is greater than negative 4x minus 23. So there's my first equation. And on this problem, I'll subtract 2x. Ooh, I want to use the blue. I want to subtract 2x on both sides as well. So I have negative y is less than or equal to negative 2x minus 7. Then I will divide by negative 1 on everything. When you divide by a negative on everything, what does it do to the inequality? Flip it. So I don't have y is less than anymore. I have y is greater than or equal to 2x plus 8. And my red equation is y is greater than negative 4x minus 23. Now, this is going to be a challenge because I've got such a big number as the y-intercept, don't I? Okay, now here's what you want to do. Yeah, I definitely made a mistake. Negative 7 divided by negative 1 is not 8. What is it? 7, and it won't let me erase it. Let's just change it to 7. This right here should be 7. Okay, so now do I have the two equations correct? I do. So since my y-intercept is negative 23, and this is my origin, I'm not going to make each line count as one unit, am I, Aaron? What's each line going to count as?
3.
Yeah, let's call this negative 3, negative 6, negative 9, negative 12, negative 15, negative 18, negative 21, and we'll call this negative 24. Okay? So you have to remember when you're doing your slope that each unit counts 3, doesn't it? So let's graph the red one. The red one says to go down 23, okay, which is going to be not quite 24, right? And then to go down 4 more, okay? So down 4, each unit counts 1, so down 4 would be dead on the line, and then right 1, wouldn't it? So like right there. That would be down 4, right 1. Or I could go up 4 and left 1, right? And so I'm going to draw a red line, but what does my red line have to be? What is my inequality telling me my red line has to be? A dotted or a dashed line. So I'm going to draw it dashed like this. That's a pitiful dashed line. That's the best I can do on this iPad. Okay, now let's draw a blue line that we go up 7. So up 3, 6, and 7 is right there. And then I go up 2 more, okay, which is right on the line, and right 1, which is right there. Okay, so let's connect our blue line. What kind of line is it going to be? A solid. Say solid. Okay, now what we have to ask ourselves is, where should I shade? Okay, the red line gives me a greater than symbol, doesn't it? So I have to take this red line and shade what? Say above it. Okay, which means I'm going to shade this area and I'm going to shade this gigantic one here. Okay, so I'm going to put a star there and I'm going to put a star there. Okay, now let's take the blue line. Here's the blue line. Do I shade above or below it? This greater than symbol tells me above, so I'm going to put a line here. A star there and a star there. Now it's clear which one ended up getting shaded twice. Which one was it? Yeah, the top section. So I'm going to go ahead and shade this all. Right? And of course the line's going forever, so I'd have to shade well up in here, right? So this is the section that gets shaded, does it not? And then I'm going to go ahead and delete these 2 stars because these sections should not be shaded at all. And then if I were to ask you to pick me a point in the shaded region, anything that fell in this shaded region, for example, if we went left 3 and up 3, we'd be right there, wouldn't we? That's the point negative 3, 3. And that would be a solution to the system of inequalities, wouldn't it? Any point in the double shaded area is a solution.